I think to the one point I made is at least with yourself when you're looking at what your goals are, like why, why do you think you need to think about an alternative manufacturing technology? Is it a time to market? Is it flexibility? Is it I can't make the part another way? Instead of just like, hey, we should look into this. Like there should be a real driver behind that. And then once you understand why, then you can start to zero in on what are potentially some of the choices that are out there.
Welcome to the Additive Advantage Podcast, the show for leaders responsible for making innovation deliver. I'm Danny Mason, joined by my co-host, Shon Anderson. Together, we explore how organizations build additive manufacturing as a strategic, scalable capability with measurable business impact. Let's get started.
For today's show, we're joined by one of the most experienced voices in additive, John Kawola, CEO of Boston Micro Fabrication. John has spent about 3 decades in this industry, from his early days at Z Corp to leadership roles with Ultimaker, now obviously BMF. And in this conversation, we explore how the landscape has changed from a pure prototyping focus to more of a production focus, what industry consolidation means both for customers and the other players and vendors in the industry, and why application engineering remains one of the biggest challenges in scaling additive. We also take a look at what separates successful production deployments from expensive experiments. Whether you're evaluating additive for the first time or trying to scale an existing program, John's perspective offers practical lessons on technology adoption, business model, materials, talent, and where the industry is going next and why that's good for you as a customer. Welcome to another episode of the Additive Advantage Podcast. Shon Anderson here, and a treat today. We've got John Kawola with us. Most people probably know him today as CEO of BMF, but a long history in our industry and a lot of exciting things outside our industry. John, what would you want our listeners to know about you before we dive in?
Thanks, Sean. It's fun to be here. So yeah, I've been in 3D printing and additive manufacturing since 1997, so almost 30 years, and had the pleasure of being involved with a company called Z Corp, which was one of the early 3D printing companies way back when, and have seen the industry evolve over the years. Have been involved in some other companies since, either as an operator or an investor or a board member. And for the last 6.5 years, I've been involved with a company called BMF, which is also Boston Micro Fabrication, which is a 3D printing additive technology company, hardware and software, typically focus on very high precision. And when we mean high precision, we generally mean sort of customers who care about sort of tens of microns. And those parts tend to also be small. So a lot of our business is in medical device, electronics, photonics, and seen lots of things. It's been a great ride seeing the industry evolve from 25 years ago, where the killer app was prototyping and often concept modeling, which I point out is still the killer app in a lot of ways, and maybe it's taken for granted, but the fact that you can have a machine in your office or your lab and you have a part in a couple hours for $5 is incredibly valuable, because before that, people would carve things out of wood, or they'd send it to the CNC shop down the street and it would take 2 weeks, and then it would come back and then it would be wrong. And so I think 3D printing already had that first wave of really being disruptive and helping engineers design things. And now so that's still the case. That's still sort of the base of where this all is. But then I think with improvements in machines and materials and software and everything else, it's sort of creeping into manufacturing, and there's been some real big wins, and then there's some places where it's still short. But I think that here in 2026, I think this industry, from a customer point of view, I mean, the technology's never been better. The choices that people can utilize for their companies are much wider than they ever were, and so and I think it's an exciting time.
Agreed. A little bit out of left field, but I'm curious, since it's fresh, your thoughts on the Stratasys acquisition of Markforged from yesterday.
Yeah. So I think one of the challenges, I think the good thing that's happened over the last 10 or 15 years is that the range of technologies and the power of all these technologies has just gotten bigger and bigger and bigger. And the dollars being spent by customers, whether they're buying machines or software, materials or parts, has not gone down. That continues to go up. And now this industry, lots of different industry reports, but People say it's $20 billion or some number like that. And years ago, it was a billion, right? So is it 20? It's probably 20 times bigger than it was 15 years ago. So that's all a positive. I think one of the challenges, and you often get this with technology disruption, is there's a whole bunch of technologies that came into the market, new companies that came into the market, starting about like 2012, 2013. There was a whole bunch of new companies. Mark Forge was one of them, Desktop Metal, Form Labs,
Yeah,
Carbon.
we were in that bucket.
Yeah, the B9, BMF started a few years after that, but there was a whole wave of that. And so the positive of that is it's new technology. It's pushing the envelope. It's making things better. It's making things faster, and it's making parts more functional. Like that's the big positive. I think the downside potentially, well, it's being realized now, is the market got pretty crowded. If you're a vendor, again, if you're a customer, it's fine as long as you can sort through all the choices out there. It's wonderful, right? But if you were a vendor providing services or technology, it got pretty crowded, and when it gets crowded, it puts price pressure, and then there was a wave of investment capital, which is not a bad thing, but they expect returns. And so the industry, from a technology vendor point of view, is going through a little bit of a reckoning now, where companies are struggling to make money. They are struggling to grow, beyond that initial burst that they have, and it's all settling out now. And so, unfortunately, there'll be some companies that go away, and if you are a company like Stratasys or one of the larger ones, it's an opportunity. I mean, you could pick up the good things that are out there, and then try to integrate them, and hopefully continue to advance those technologies forward. But it's a bit of a bumpy road right now for technology vendors, because that sort of shakeout is happening.
That's, I think, a well-rounded perspective. I'm curious about, you've been in businesses that were heavily distribution driven, thinking back to, Ultimaker as an example, et cetera. And then you've been in and run companies that are much more direct to customer, B2B focused. Give me your thoughts based on where the industry is today and what customers need today. What, if you could start from scratch, and which is a little unfair when you ask a CEO of a company that question, but if you could start from scratch when you think about business models, go-to-market models, et cetera, what suits the context?
Yeah, so if you boil it down a little bit to the choice between like selling direct versus selling through distribution, there's a number of factors there, and I've been through this a couple of times. There's actually, this again dates me how old I am, but there was a Harvard business case study 20 something years ago when we were at Z Corp, and we were trying to decide between, do we sell direct or do we sell through distribution? And at the time, our product was about $50,000 or $60,000, and we were not a big company. We didn't have a lot of capital, and we had to make a choice. Are we going to sell direct, or are we going to sell through distribution? And there's pros and cons with each. When you're selling direct, the pro is you're probably much more engaged with the customer. You can, probably have more control over what's going on, but it's expensive. You got to pay your sales team, and to be able to reach around the world quickly, it's hard to do, right? So eventually, Z Corp, we actually moved to a distribution model, and so we moved to selling, because what we found is we were selling direct in the U.S. We had a couple of guys, driving around, and it wasn't strategic. It was just we didn't have the money. We hired resellers in Europe and Asia, and it worked really well. So this goes back to 20 plus years. And so then we switched everything to distribution, and that worked pretty well. And it worked well because the price point was a comfort point for the channel. The channel was historically people who also sold CAD software or printers and plotters. So they were, hopefully visiting the same types of customers. That worked really well. And when you get into a much more, I'd say, advanced or technical or even expensive product, where the sales process is longer and there's more hoops to jump through and more benchmarks to make or more tests to be run, I think that becomes more challenging with distribution, unless you have very specialized distributors who know how to do that. So with BMF, we sell primarily direct in the big markets like the US. We have a big organization in China, in Western Europe, and we sell in resellers. We do have some resellers, but again, this is not strategic. It's just we can't afford to have a person in Australia. So we have a reseller in Australia, and we have a reseller in India. And so we have places where we can't practically sell. So we've chosen to have both of those models. And then, I think the opportunity and the challenge with selling through distribution or resellers is hopefully you have a channel out there that's well suited for what you're selling. Because in a perfect world, what you'd like, You'd like to have resellers who are selling something that's maybe adjacent to what your product is. They're already visiting all the customers you'd like to get. They already know them all. Like that's what you want. If that channel isn't ready made for that, then you're starting from scratch and trying to. It's much more education. So in the early days of additive manufacturing, and it's still pretty much true, a lot of the channel were the CAD VARs, which was perfect, right? Because they had already sold them Autodesk or SolidWorks or other products, and they knew that a 3D printer offering was a nice sort of adder to that.
Yeah, it's interesting when you think back to I'll call it, innovation plus capital fueled explosion that happened. You had so many companies pursuing largely the same channel and it just getting mind share. And B9, very similar to the situation you described with BMF, where the vast majority of our business is direct. Certain countries where, for import, export and local support, et cetera, we have resellers, one or two vertical resellers in the US. But, I think it was, to your point about it's hard time to be a vendor when, so many new products being introduced and hard for the OEMs to get mind share in the channel. Now that is shaking out and the field is narrowing a bit, if you look into your crystal ball, because everybody expects CEOs have a crystal ball right in your pocket. What do you think the additive channel world looks like over the next 5 years as you see the consolidation or in some cases just elimination of some of the players in the market?
Yeah, I mean, I mentioned before that the technology landscape got crowded, but then it also became crowded for the channel. So one of the reasons we chose to go direct, primary reason we chose to go direct in the United States, for example, is our product is sort of starts at $150,000. It's a technical sale. It takes a long time. We're going to end up doing a lot of the sales work ourselves with our engineers. But that was one reason that we didn't go through channel. The other reason is the channel was crowded, right? Because they sold a whole bunch of different products. And to your point, Shon, about shelf space. So I think that the challenge, I've never been a reseller, but I can sympathize with some of their challenges. Their challenges are products become commodity or a little bit more commodity. They're facing competition not just from other brands, but from the reseller across town who's selling the same thing they're selling. Right. So that's a challenge. I think margins have been compressed for a bunch of resellers. And so I think the best of the resellers in any industry, I think, are the ones who have adapted over time. And to believe that you can sell the same thing for 20 years is probably not right. That you have to hopefully try to have their own crystal ball to try to bet on, okay, we think this is an emerging technology. Hopefully we can sell that. We're not going to sell that anymore. So I think the most successful resellers are the ones who've ridden the wave that they could ride, but know that that's not going to go forever and they have to jump on something else. Interestingly, though, I used to think when there was only a handful of 3D printer reseller, 3D printing vendors. So this goes back 20 years. I used to think, and maybe it was bravado on my part, that the OEMs had all the power, and because I still believe that was true. So because there was only a few of us, we all had exclusive contracts, and we could add resellers or fire resellers. I actually think that's flipped now, where I think a lot of the resellers have much more of the power because there's so many choices, and they can pick and choose, and they can start to push back on exclusivity. So I think that dynamic changed over the last 5, 6, 7 years, where I think that if you have a strong distribution company, you have more choices now and you have more leverage potentially over, the products that you sell.
Yeah, it's interesting how that changes over time. One of the other dynamics that I see happening that I've been dying to get your input on is, in the heyday of all the SPACs and all the money flowing, these companies were doing a whole lot of what I would call application engineering for free. And there was support flowing to the channel to make that happen. And now you've seen that significantly dry up. So who should step in and fill that role? I mean, you have OEMs, the largest of which aren't profitable today and have had to cut significantly to try and get to profitability or cash neutrality. You've got, in what I see is this network of channel partners who, promotions aren't what they used to be, discounts aren't what they used to be. Where does that application engineering help come from in the world we live in today to help customers succeed with this technology?
Yeah, it's a great question because regardless of your gross margin as a vendor, you might have a very good gross margin, but if your cost of sale is so high because you got to do benchmark, test. I think each OEM has to make their own judgment about, should we charge the customer for this? Should we try to get some sort of NRE in terms of development funds, or do we do it ourselves, right? And I think I don't know if there's one right answer there. I think each OEM has to. It's a judgment call, and you're making the judgment call like this is going to be worth it because we're hopefully not just going to get that first sale, but it's a continued sale, or it opens up a market. What I've seen that the OEMs generally are best suited versus the channel, in my opinion, of doing the applications engineering if it's associated with materials or hitting specific tolerances. This is the sort of the world that I live in at BMF. Like people come to us because they really care about the tolerance. And then often we have to prove that, yes, we can do that, but also the materials are good enough. And yes, this will work from their application. We generally don't go down the path, though, of doing, I'll call it functional testing or environmental testing. Because I think, we'll do basic things. When we have biocompatible materials, then we test all those. But at the end of the day, the customer themselves have their own need in terms of how strong the part needs to be, or what temperature it needs to operate in, that we don't have a lot of visibility to. So all we can do is they can tell us what they're going to do, and we can make the best part we can make for them, and then putting it on them to do the testing. And that we found that generally works. It also, sorts out who's serious and who's not serious, and are they willing to invest in trying to get this to work. What has helped us as a company, and it's probably true for you as well, Shon, our technology is used a lot in engineering and development, primarily. And then some things are crossing over into production applications. And in almost every single case where it's crossed over into production applications, the customer at least had one machine. So they were buying it. They bought it. They started using it. They started testing it. They started understanding what it could do and not do. And they were able to do that because while we're expensive, we're not $1 million.
Mm-hmm.
We're $150,000. And so if we were $1 million, they wouldn't do that. I don't think, in my opinion. And so that's I think what has made it hard for some of the companies that entered the market that were production only, because for anybody to commit that amount of capital, they needed to feel like it was really going to work. And that's a long road. So our experience has been the success stories in production are people who brought a machine in, bought it, tested it, tried to get it into production. And worst case, it doesn't work for production, but they use it for prototyping and they're happy.
Yeah, it met the business case they originally invested in.
Right.
Around. Yep.
Right. Yeah. And so I think that's part of the challenge. But when you get into the actual application where people need a certain temperature or a certain humidity or a certain dielectric constant, or whatever all these things need to be, we tend to try to push that off to the customer. Because if they're serious about it, then they'll do the testing. And it's at the end of the day, it's going to be their testing that matters. Even if we did all the testing, they would probably do it again, right? Because they're not going to trust. They're not going to be able to use our data to validate their process. They're going to have to do it themselves.
Yeah, especially when you think about a production application where they're placing the bet that, hey, this product, if we get 100, 1,000, 100,000, whatever the number is in the field, right, it's going to perform the way a traditionally manufactured part would have performed. And that's a big bet to make based on a data sheet that any OEM sends out with a set of materials. Because to your point, and I think this is what I see customers underestimate oftentimes. And since we're both mechanical engineers, I'm going to pick on them a little bit. But, you'll be talking to a customer and they'll say, well, we make this out of Delrin today. That's what we're looking. It's Delrin. What do you have this like Delrin? Well, which property? Delrin has, we could talk about 50 different attributes, right? And oftentimes that material got chosen by an engineer just because he or she was familiar with it, or they designed a similar product and they used it in that product and so, hey, I think it'll work here, not because it had a shore hardness of X or a heat deflection temperature of Y. And so you're dealing with, this design context that sometimes even your customer doesn't really know. And I think that decision to say, Mr. Customer, if you think it's worth, going down this path, here's the investment you need to make, and letting them carry that water. I think there's a lot of wisdom that others could learn from there.
Yeah, and then all the materials have, 6, 8, 10 different mechanical properties, and we've found that usually for the application, they only really care about one or two things because depending on what it's going to be used for. So that's usually what we try to ask. Like, what do you care about? Do you care about bending strength? Do you care about hardness? What's the most important thing here? And it helps them, I think, also think about being open to the materials that are not Delrin. So,
Yes.
because
Yeah.
especially when we both operate in a business where the materials that we offer are photopolymers or thermosets, and most people are using in historically in engineering are using thermoplastics, and so we try to be upfront to say, well, we have some materials that approximate, we believe, what you want to achieve, but at the end of the day, you're going to have to test it to see if it works.
Yeah. Well, let's get into the conversation a little bit around, applications. I'm interested. You mentioned, obviously, people tend to start with, hey, how do we use this in prototyping, engineering, maybe doing some short run stuff. But you're seeing some customers now bridge that over into production applications. What is it that you see in common about the customers that do that, or maybe the applications that succeed in making the leap to production? In a general sense. And then I do want to get into that more specifically around the world BMF plays in of this, tens of microns space. But I'm interested, what you see in a general sense first.
Yeah. So I think in a general sense, and this applies, I think, across the industry, is that the driver, there's got to be some driver that's pushing the company to think about an alternative manufacturing process. It's like there's something. I mean, when we think about, some of the things happening in the sort of defense industry or the, repair part industry, for metal parts for defense or repair, what's the driver there? I think the driver there is speed. Like, how fast can they get this big metal part that is normally cast and normally takes 18 weeks? I think the big driver there is speed. In the world that we live in, a lot of the driver is around things getting smaller. And so our company really exists because there's in a lot of different industries, there's a driver for things to get smaller. So in medical device, there's just an overall trend to make the procedure less invasive, or to make the implant smaller so it has less of a chance for infection. So there's always this: can we make it smaller? And in electronics, it's just physics. When things go from 5G to 6G to 7G to 8G, the antenna actually just has to get smaller. Like, that's just a fact. And so what that driver then forces the engineers to think about, oh, okay, well, if the antenna has to get smaller, the packaging has to get smaller. Oh, how do we make it? And so those are the outside drivers that that we see that are forcing people to at least consider it for production. And then they have to go back and check all the boxes. Is the materials good enough? Can we get repeatable parts? Do the economics make sense? But if you don't have that initial outside driver, then it doesn't happen, and it doesn't make sense to happen. To be honest, they should use conventional manufacturing methods that are proven and much, could be considered lower risk.
Yeah. It's interesting how, and I'm guessing you guys have maybe had a similar conversation with different customers, but sometimes the right answer is get a better or closer vendor for your traditional manufacturing process instead of using additive. And I think, again, back in the lots of capital, lots of innovation, there were companies that are like, wow, we need to figure out how to use this additive manufacturing thing. And so there were some, message in a bottle type projects. It's like, we're going to throw an engineering wish in this bottle and throw it into the ocean of additive and see if it floats to somebody that can help us. That I don't see that happening these days nearly as much.
No, not as much. Now, I mean, I think the undercurrent still, though, is, it, as I said when we opened up this conversation, like for any engineering or product organization making a product, It absolutely makes sense to have a 3D printer. For prototyping, development, short run testing. We do a lot of, we have more cases of people needing, and these aren't, I'm not going to say they're production parts because they're not production parts, but they're sort of bridge parts where they need 5,000. And we're like, what do you need 5,000 for? Because they're going to do testing. And I was like, well, but these aren't production parts. So yeah, but we're able to test what we want to test.
Yep.
And we're not going to, and we might change our mind based on the testing, and therefore we don't want to go to tooling. And so it's like those things are home runs. Like people are like, yeah, we're going to do those things. It's when they get to that final step where they say, okay, now we need to make, we want to make sure this is exactly the material we want, and the volumes are at a level that justify tooling. But I think there's still, we see a lot of business for us, and I assume a lot of other people who are in this space are doing. Again, I'm not going to call it production, but it's sort of in between, where it's beyond prototyping, but they want thousands.
Yep. Yeah, and to your point from early in the conversation, the technology's good enough today, and most of it fast enough today that, it used to be if you needed more than 10, maybe we should call somebody. Today, if you needed 1,000, that's not
Right.
a big hurdle.
Right. Yep.
I'm curious to go back to something you mentioned a little while ago as we think about these applications that can make the leap into more of a production mindset. And you mentioned, BMF, of course, you guys play in the world where tolerance is vital. If the tolerance doesn't matter, probably those folks aren't on the phone with one of your sales guys, I'm guessing.
Right.
So, and obviously production repeatability is huge when you're talking about making a part that you're actually going to send to your, the customer's customer. What does that look like for you guys when a lot of your machines operate in a world where the old engineering thing of, plus or minus 5 thou, I mean, BMFs, I don't even know do you guys even make a product that's that loose? I don't think you do. What does production repeatability look like, and how do you cross those hurdles when you're living in this kind of like plus or minus 10 microns, not plus or minus 10 thou world?
Well, I mean, our machines are designed for that, right? So our printers are designed to be able to make parts in that sort of pocket of plus or minus 10 microns or plus or minus 20 microns. And then you need the inspection equipment that is not calipers. Calipers won't work. So, you need a Keon scanner or something like that. And, but fortunately, our product is our platform is sort of robust enough and repeatable enough that we can dial in certain tolerances, and then when we make 100 parts at a time at a certain build, then we don't have to inspect them all, right? We inspect the middle and the outsides, and then if there's a confidence level that gets built. But that's true for any manufacturing process. You dial, whether it's molding or machining or stamping, or you dial it in. You probably in the beginning you inspect every one to make sure, and then you gain a confidence like, well, I don't have to inspect every one. I have to do every day or every batch or every build or something like that. And so, yeah, we just do it at a sort of tight level of tolerance. And we recognize every day that's why we're in business. Like, because if we didn't do that, we wouldn't be competitive. We wouldn't have a portion of the market that we can try to play in and have some advantage, because there's lots of great solutions out there that are less expensive than ours, and that work perfectly fine and can hold the plus or minus 5 thou, and for lots of applications that's fine. And so we sort of embrace when people give us those tolerances, because that's why we exist. And if they weren't giving us that, they wouldn't be calling us, to your point.
Yeah. Similarly at B9, we've had to just condition our, from the sales team, the solutions engineers, and our product engineering team, like other than our jewelry business, which is, a piece of the company that it's where we got started and continues on. But a lot of the other things we do around aerospace, med device, et cetera, like the reason they're calling us is probably because the other guys couldn't hit the mark. And
Right.
so,
Right.
we have to pick up the phone, metaphorically, knowing we're talking to an engineer that, is on strike 2, and maybe vendor 2 or 3. And, we joke that, we aspire to have a marketing budget someday that would get people to call us first, but we're, typically after the other guys strike out a couple of times, we get that call. I'm guessing some of your sales team experiences similar things.
Yeah. Yeah. I mean, they call us and then they go away and they come back a year later. But
Like, hey, that's
I think
too
something,
expensive. We'll get it done with somebody else, and then they
I think
figure
there's
out.
something that B9 does well, that almost all the other OEMs, including BMF, to be honest, is you guys are flexible enough to do custom implementations, I'll call it. Customize the software or work with a client around a certain installation that meets certain requirements that are not standard. And I think that's been an advantage for you guys because most of the OEMs don't do that, including we don't do it very well. So because it requires, an organization that is set up that way. So I think that's an advantage that you guys have.
Well, similar to you guys' commitment around accuracy and tight tolerances, I mean, we're not as far on that end as you guys are, but we have viewed this, not only willingness to adapt the technology to the application, but frankly, ability to do that well as kind of how we keep, our niche carved out. And it's been a good, I think, value add for us and for our customers. I'm curious, you've mentioned a few times, John, obviously like BMF, your printers are designed when somebody brings up this plus or minus 20 micron, whatever, you guys don't blink because your stuff's designed to play there from a hardware standpoint. Talk to me a little bit about when you get beyond the hardware and in the materials and software side of the equation, what it takes to really make that entire workflow perform. Again, thinking about somebody who wanted to move toward production.
Yeah, because they are all tied to. It's not just as you know, it's not just the hardware. I mean, we need to have the hardware be solid and that the machine tolerances themselves are plus or minus 1 micron. So it's sort of very tight, I'll call it, from a hardware point of view. But we're also dealing with photopolymers that you're imaging with light and there's heat and they shrink, and so you got all those things happening at the same time. We also stitch, so to be able to if you have a part that's bigger than our zone, you have to be able to put it together. And so, yeah, all those things are pretty critical to get to the end part that you want. When you get to a more of a production environment, it's just making sure that's just dialed in, right? That the machine is dialed in, that the software settings have been validated and are being used over and over again, that you're paying attention to the materials, that making sure you have good fresh materials and they don't age over time. So there's a bunch of factors there when you're trying to get to repeatability. And whether it's a project that we've done or some of our customers have done, it just requires a little bit of a thoughtful quality control program, which is, again, maybe not inspecting every part, but just knowing what you need to check, knowing, what sampling are you inspecting, how often should you change the materials? When you get into somewhat regulated environments like medical device, you absolutely have to write all that stuff down because it's being required as
Right.
part of the product. And so, and it's being required because if the whole thing is if something goes wrong, they're going to come back and they're going to ask you for it. And so you need to do it, but doing it also helps you make a better product. So it's not just make work because the regulations say you have to do these things. I think our experience is in a lot of cases, some of these regulations and quality control programs are having the QMS in place makes your ability to it helps you make the product or the program successful.
I'm curious, touching on that QMS and kind of those after the print steps. And clearly you guys are keyed into, you have to be able to come up with a QA QC approach that doesn't require 100% inspection, or usually the financials won't survive, ongoing 100% inspection, unless the part is really, really expensive to make. We've seen, and you joked about the calipers, although we've seen that so many times, like somebody wants a tolerance on the part way less than the tolerance on their Craftsman dial calipers or their Harbor Freight digital calipers. And I think up until I'm going to say last 2 or 3 years, I saw a lot of reluctance from customers to invest in that. If it, Keyence, Mitutoyo, whatever kind of optical inspection equipment that you mentioned earlier, because I think they were so used to being sold that 3D printing was a genie. I just rub the printer, the parts fall out, they're perfect. Well, that's what the sales guy told me. I'm seeing that change. Tell me what you're seeing. And again, I'm interested because you guys live in this hyper tight tolerance end of the world. What are you seeing about customer attitudes to post-printing inspection and having to invest? It's not just I got to buy this $150,000 machine. I'm going to need the right equipment on the back end. What is that changing? What are you seeing?
Yeah, I think it's changing with more education and the people who've been around additive for if they've been exposed to it in any way over the last 5 or 10 years, they understand that you've got to take it out of the printer. They understand that you have to rinse it off. They understand you might have a post cure. They understand, there may be support structures that need to be removed. And so I think as the greater community of people working in this space have been exposed to all these things over the years, there's more education. But you're right. I mean, there's people who have not done this before, and they walk in and they go, and then you show them, well, we're going to print them, and then we're going to show you all the other steps, and they're like, oh, okay, all this kind of stuff in terms of post processing and inspection and curing. This is true for whether you're doing photopolymers or whether you're doing thermoplastics or whether you're doing metal, or there's always a level of post processing or post curing or sintering or something that has to happen. Interestingly, though, I think that's in the short to medium term, I think those are the areas that can be automated the easiest versus the printer itself. We have a couple programs where, and again, a lot of this is not, when I say automation, I don't mean sophisticated robotics. I tend to mean, you do a project, and then over the course of a few weeks, you realize you figured out just significantly better ways to inspect or to post cure or to yes, printing it this way is faster, but if you print it this way, there's no supports, and so therefore the net benefit is we're going to print it this way. So a lot of that's learning. I mean, we've also found the use of fixturing for quality control. So like go no go type fixturing is really valuable, but you're not going to figure that out until you start making the part.
Yeah.
Usually, you're inspecting it, and then you realize like, well, why don't we just make some gauges here, and then it'll be way faster. And so I think those are areas that are more ripe for automation, and there will need to be that because otherwise the cost and the labor cost primarily of doing a lot of that post processing, depending on where you are in the world, could be prohibitive.
Well, and I know, so it's interesting to me, in my mind, if the glue that holds all this together is this expertise around all these topics, from the application engineering on the front end to QA QC processes on the back end, it's got to come from somewhere. Now, you see the big companies, and a lot of them have been automotive and aerospace, but whether you're Ford, BMW, whoever, that yes, they put a team of 10 engineers on figuring out this additive thing 20 years ago, and they are, on the cutting edge of what they can do. They've got 3D printed parts on cars, et cetera. But when you think about the distribution of manufacturing companies, it really is this bell curve where, of the very large ones who can afford that kind of investment, there aren't very many globally. The majority of companies are this big hump under the middle of that curve who can't afford to put 10 engineers on this for 10 years before they get, real production applications. And as in my mind, everybody's like, well, I want to see these printers get cheaper and cheaper and cheaper. Like, what if I could get a printer for $1,000 that would do all this stuff? Well, that would be cool. Where would the application engineering and implementation support come from? Because there's not a high enough percentage of $1,000.
Right.
If the thing fell out of the sky and mythically landed in a box, $1,000 won't cover that. So you come all the way back to this full circle business model thought process around, well, even if your gross margins were 100%, if the customer wants to buy a $1,000 piece of equipment, there's not enough money in there to cover helping them figure it out. So you have to, I think when you look at what's going on in the market, obviously Chinese companies have done really, really well. You talk about that $150K price point, but you guys came out with a new product earlier this year that was, I'll just call it, more accessible from a financial standpoint. Certainly not trying to produce $1,000 printer, but lowering that barrier to entry. What do you think customers should expect? I mean, at what point do the industry and the customers kind of have to say, here's what we can both live with that's a win-win, where we can afford to give you the support and expertise you need, but you have some choice and you don't feel like you're being held hostage and being charged, whatever two OEMs agreed to charge you. How do we come to a happy resolution of that?
That's a hard one because, right? I mean, we're all, as vendors, we're trying to be competitive. We're trying to get the business. And so what does that mean? Maybe we're lowering price. Maybe we're giving away too much stuff, and because we're all trying to survive to a certain extent. And if we all got together in a room and said we're not going to do that anymore and we're going to raise pricing, I think that's sort of illegal. So you can't do that. So a lot of it's just sort of the market. In some ways, I think this expertise gap has been the big opportunity for service bureaus. That's why service bureaus thrive or can thrive, depending on the technology they choose and the markets they serve, because that's all they do. Right. I mean, they have that they've invested in the equipment. They invested in maybe multiple different types of equipment. They've invested in the post processing, and the customers maybe not, the end customers maybe not, they're outsourcing it. Right. They're outsourcing the use of that technology, and they have to pay a fee for that. Right. So they're not going to get it for free. They're going to pay the cost of the part. But I think that the service bureau sector has continued to be vital through all this. I mean, there were lots of people over the last 20 years who said, "Oh, the service bureaus are going to go away because now companies can have their own printer, right? And they don't have to have a big sophisticated room, and they don't need to have nitrogen." And then even as the price went down even further to when Z Corp came out 25 years ago, we were the lowest price thing on the market. It was like 50 or 60,000 bucks, and then there were other competitors in that price category. And then 10 years later comes the desktop wave. And so lots of people wrote off the service bureaus to say, well, everybody's just going to make these parts themselves. And that didn't happen at all. And so I think it further entrenched the technology across prototyping all the way up into production. And, when you get into real sophisticated technologies, metal, and, these are, lots of companies don't want to do that and want to outsource that. And they pay for that. And so it's that gap right now has in my view, kept service bureaus being a vital part of what's going on out there.
Agreed. And at the end of the day, some of that comes back to a talent decision, right? Like, can we, as a company, whether you are an OEM, whether you are a channel partner, whether you are an end customer, can we attract the kind of talent and retain the kind of talent and provide a career path and all those things for the type of talent we need to make that play work internally?
Yeah.
And I know we've seen in our customer base, a lot of people have really underestimated that, because oftentimes that talent or that, man or woman who needs to come in and run that additive piece, it's a different skill set. And we have had some customers who've really recognized that. We did a big project for Thermo Fisher where we helped write job descriptions of the technicians they needed to hire. And, they recognize, hey, this isn't exactly like the rest of our workforce. Now, that doesn't mean, that you need people with a third arm, but there are differences there. And I think people sometimes underestimate the human side of it.
Yeah, it's interesting. I've seen a couple sort of skirmishes about labor and skill set over the years, where companies would assume that they would bring in a printer and the engineers would just run it and everything would be fine. And were a lot of these engineers fully capable of running it? Sure. Did their boss want them goofing around with the 3D printer 3 hours a day? Absolutely not. Right. Like, so we had this issue when I was at Ultimaker some years ago. There was a big question about basically how many dials can you turn. And so there's a camp that just wants to press the green button, and there's a camp that wanted to have all the dials, right? And we had plenty of customers at the senior level no, I do not want all the dials, because it just means my guys will be goofing around with that all day and they're not doing their job. And which is a valid point, right? And so I think it depends on the organization and what they expect their engineers to be doing during the day. Are they designing and thinking about the next thing, or are they goofing around the 3D printer? And there's a balance there. And I think the companies who do it right, choose the right printers for the people that they have, or they if it requires more expertise, and then they hire a technician, right, who maybe is the provider for the office or the team. But that can be somewhat complicated.
Yeah, we've seen, and I got a real life example of this. I won't say their name because I don't want to embarrass them, but invested in some of our technology, having a lot of success. Like, okay, we're going to take this, similar to a story you shared. Like, hey, let's see if we can take this into production. Hey, this is working great. And we I will say from our side, we tried to sell them some services to help that happen. They're like, no, this is working great. We got it. And then a few months later, they're like, well, turns out it only works great when a team of engineers is doing this. I know you guys have told us you've got these things in production where it's, production technicians. Okay, uncle, how do we do this? Right? Because when we pull our engineers off this, we lose control of the process. And it was going back to things you said earlier, John, a lack of precise documentation around some of those, what we would call production processes that the engineers in their mind, well, I don't need to document this. This is just how I do it. Well, if you're going to hand it over to to a technician, you need a thoroughly documented workflow. It was more about documentation and training than it was about, can a technician actually do it or not? But we see those things happen on a somewhat regular basis. One of the other things I'd love to get your thoughts on is big change in the industry is we saw a ton of the big material companies come in, the BASFs and all kind of anyone who's anyone, Mitsubishi Chemical, a lot of others made big investments. And since then, they've all kind of pulled back. What's your take on where that leaves the industry in terms of both OEMs and customers? And because in my mind, it's kind of like you've shared, you didn't use these exact words, but the hardware is already good enough. I can't think of very many things that now it might mean you need to buy a BMF, right? If you really need that gnat's eyelash tolerance, you might have to, maybe you can't use a $4,000 printer. Maybe you need the $50,000 printer, but there's hardware that can do it. The materials seem to be the gap on a number of applications. And how do we get across that without investment from all these big players?
This was another thing that, similar to the sort of the venture capital wave that happened and all these new hardware companies came into the space. A lot of the big, plastics companies and chemical companies came into the space, starting 10 years ago. It used to be, so you go back, again, I go back to my Z Corp days 20 years ago, all the OEMs, Stratasys and 3D Systems and others, we all had our own little material science departments. They weren't very big, and we all made our own stuff, and we all had the customers buy from us. And in the short run, that was a great business model. So, but if we were honest with ourselves, at Z Corp, we had we had some people, and Stratasys had some people, and 3D Systems and some other companies all had people. But these were not the best, arguably the best talent out there in plastics engineering, And the reason is because we all had closed systems. And so when those guys called up to want to participate, we told them to go away. And so, they all showed, okay, can we do a joint? No, see ya. And so in the short run, that served us pretty well. What happened, which was, I think a positive, is these as systems became more open source or open materials or whatever you call it, that opened the door for the big companies to come in and invest. And now these are, multi-billion-dollar chemical companies who supply plastic pellets by the trainload to, all the industries we know of. And a bunch of them jumped in and said, okay, we'll have a 3D printing business. And I think they did that for two reasons. One is I think some of their customers asked them to do that. Like, hey, think about their big OEM customers said, well, maybe we'll be 3D printing someday and we would offer you to be. One, they asked them for that. And two, it was a hedge against, well, maybe it's true everything will be 3D printed in the world and we're going to miss it if we're not in it. And so a bunch of them got in. And I think it was positive for a number of years, because I think it definitely pushed the envelope in terms of the quality of the materials. If you had asked me 6 or 7 years ago, could you do functional photopolymer? You live in that world. I live in that world. Functional I would have said, SLA. No, I don't think so. But all that collective group of companies all pushed that envelope, and now you have flame retardant materials and tough materials and biocompatible. You have all this range of materials. I think the challenge, what happened in the last 2 or 3 years, is all these big companies realized, at least in the short run, it's not $1 billion business for them. It might be $100 million business for them, which in the world we play in, we'd be like, well, that would be great. But if you're DuPont, they're not doing that. So I think that's what's happened in terms of as it's scaling back. And unfortunately, I have to admit, it has probably slowed the collective advancement of materials development. And it may fall back on the equipment OEMs to really push that envelope. Now, I think Stratasys is maybe trying to take advantage. Stratasys has invested in and brought on some of these groups, BASF and a couple others. And so I think they're going to try to use that and leverage that and push that. But I think, I had hoped, and maybe you had hoped, that the photopolymer world would continue to expand and therefore would help our business push along. And I think that has cooled off a bit.
Yeah, agreed. Well, it's been a fantastic conversation. I've got one last question that I want to hit you with. And it's in some ways maybe a little bit of a gotcha, but it's really about how do we help our listeners where the rubber meets the road. And that question is, if you were a manufacturing leader, John, and you just listen to this podcast and you just absorb this perspective and some of the best practices, and you said, okay, I get it now, and you're tasked to go implement additive in a production context, what would be your first move based on some of the insights that you think came out of our conversation today?
Yeah, I think to the one point I made is at least with yourself, when you're looking at what your goals are, like why? Like why do you think you need to think about an alternative manufacturing technology? Is it time to market? Is it flexibility? Is it I can't make the part another way? Instead of just like, hey, we should look into this. Like there should be a real driver behind that. And then once you understand why, then you can start to zero in on what are potentially some of the choices that are out there, and talk to the eager salespeople that are out there, and get samples, and try to become as educated as possible. One of the challenges I think in manufacturing discrete products, as good as some of the support groups are, and AMUG and all these other things, generally companies don't talk to each other because they're not supposed to. They can't. Well, which is a valid reason. So it means there's lots of companies who are doing probably amazing things with additive in production that people don't know about, and that's just life. But if you're thinking about incorporating these technologies, clearly understanding why, and then trying to understand, can additive make a difference? And if the answer is no, the answer is no, right? But I think there are lots of cases where it can, where whether it's geometry or whether it's time or whether it's flexibility, then there's some amazing technologies out there, whether it's plastic or metal, that can do these things now that they couldn't do 5 years ago.
Outstanding. Thank you for that. John, it's been a great time. Always appreciate your perspective as we've gotten to know each other over the last few years, and, your ability to translate lessons learned from, what'd you say, almost 30 years in this space to the reality of what people are working with today. We'll look forward to hearing from you again and catching up with you in the future.
Yeah. Thanks for having me. Appreciate it.
You bet.
It was a great conversation. It's always wonderful to talk to someone that has seen this evolution and not just over the past couple years. And one thing that really struck me is how much you talked about you need a driver for additive manufacturing. I thought that was a unique perspective, and I'd love to get your take on it and share maybe how that differs from some of the other conversations we've had.
Well, you can look at this through a lot of lenses. And I think John's point was you need a why if you're a company and you're going to undertake, exploring additive or using additive. And it's got to be more specific than, hey, this technology seems pretty good. We should find a way to use this, right? If you don't have a clear mission in mind, it's difficult to measure success. And I think his point, when you look at the true cost, not just the hardware, software, materials piece, but the entire production workflow, the human resources associated, et cetera, if you're not measuring that against the size of the pain that drove you to go down that road, it's difficult to know if you were successful or not. Seems a little bit obvious, but I will tell you that has been a recurring theme of all the guests that we've interviewed. When you look at, what does it take to do the entire production workflow from the human resources, if there's production equipment, inspection equipment, all of these things. And I'd like to assure you in the audience, this is not Danny and me stuffing the ballot box, encouraging people to talk about this. I think what you're hearing is from folks who've helped companies have to wrestle their way through this to success. Here are things people forget to think about. So don't be one of those people, and take those costs into account. Never forget that it isn't just a can we do this with additive, it's should we do this with additive. John, there were comments multiple times about you might just need a better vendor with your traditional
Yes.
manufacturing method, right? Additive is not the answer to every pain point, but remembering what that driver is and then sizing and judging your investment against that original, pain or opportunity is so key.
I want to double click on that because a lot of companies are trying to figure out, where do I invest in AM? How do I do it successfully? And he brought up the point that the machine is not only not the whole part, it's maybe not even the most important part. And to your point, it's not that these themes are novel, but we aren't bringing them up. Customers are bringing them up, which tells me that they're pretty critical for making good investments. Can you unpack that a little bit in terms of what people should be thinking about when deciding where and how to invest in additive?
Well, I think it comes back to, again, I'll go all the way back to the driver, right? What problem are we trying to solve? And then what would success look like? If you can define those two things, then it gets relatively easy to say, what are our technology choices? Who are our potential vendors or partners that we might leverage to do this? And then, again, when you look at, and Danny, because we've had customers who've needed help with this, not just who's going to print the parts. And is it, John and I talked a little bit about, you've got customers that might succeed when their engineers are running the process, but when it comes time to hand it off to the folks on the factory floor, results are much less successful. And really thinking through, what are we going to have to do to have the right training, the right documentation, all of the things it takes to make this succeed in a factory environment if you're wanting to go to production, rather than just, hey, let's throw that new engineering hire. He came out fresh out of college, right? He probably knows how to run a 3D printer. Let's throw him at this or her at this and see what happens. Having a solid investment thesis for the whole production workflow is vital. And I really think, because I've heard this from, CEOs like John, I've heard this from some of the high level folks, all the way back to your conversation with Paul Chabala. I think this is just Shon's distillation here. When we look at how these conversations get off track, where you have an executive who says, hey, we need to look for opportunities to leverage additive, or we need to shorten up our supply chain. We need to get out of this, tons of inventory, high MOQ, lots of cash tied up. Inevitably, a technical professional gets involved. That person then proceeds to start slicing and dicing and figuring out how to solve the problem. At the end of the day, when I'll call it true up happens of, well, what did we invest in total and what results did we get? I think that the loss of shared vision for how big is this problem we're trying to solve and how much are we willing to expend in terms of, capital, talent, et cetera, organizational capacity to solve it. I think when the handoff happens on the front end, between that handoff happening and the true up on the back end, the driver gets lost and the why gets lost. And that's why when the true up happens, oftentimes folks are not pleased with how that turns out. I can't do anything but say it out loud. It's so important that you're working with a partner that understands what the whole production workflow takes. And, John did a great job of bringing up the importance of the application engineering.
Yes.
And we had some interesting conversation about where's that expertise going to come from? Sourcing a piece of equipment, no different than traditional manufacturing. If you have an engineer, you're going to stand up a new line, milling, molding, whatever it might be. You get your engineers to spec out some equipment, talk to some vendors, maybe bring back a couple of options. But who are the people that are going to have to own that and operate that equipment and bring that to life later? And where are they in the conversation, especially when you're talking about a relatively new thing like additive? I just think there's so many lessons to be learned there. And again, the fact that it comes up over and over and over tells you it's a watch out.
Absolutely. What a great conversation.
A big thank you to John Kawola for joining us on the Additive Advantage podcast and sharing those insights from his 3 decades in this industry. One of my big takeaways is that additive adoption at scale successfully is not just about the printer. It's about understanding the business problem you're trying to solve, whether that's speed, flexibility, miniaturization, supply chain issues. The organizations getting the greatest results are the ones that start with the application and then work backward to nail down the technology around hardware, software, and materials. As additive continues to mature, the winners won't simply be the companies with the newest hardware, and we are seeing that in the industry. They'll be the companies that develop the expertise, the processes, the quality systems, and the organizational capabilities required to take those technologies and turn them into repeatable business outcomes. If you enjoyed this episode, be sure to subscribe, share it with a colleague, and join us next time as we continue to explore the people, technologies, and strategies shaping the future of advanced manufacturing.
And you can follow us on Apple or Spotify or watch this episode on YouTube at the Additive Advantage Podcast. If you enjoyed it, leave us a 5-star review on Spotify or Apple, and be sure to follow us on LinkedIn for all the updates on our latest episodes. Thanks for listening. See you next time.